This project came out of an idea I had a while ago to 3D print a 3D printer. A long time and a lot of procrastination later, it's finally complete. Let me show you how I designed and built it. When I started this project, I wanted a printer that would be small, use a fully printed frame, and be cheap, fast, and easy to build. For the parts, I tried to get things that blended performance and compactness. I used a Bambu style hot end because it's actually tiny, and you can get clones for like $10 these days. I chose to use linear rails on the X and Y axes. These can be fixed directly to the frame to boost rigidity. Oh, and before I move on, I forgot to mention that I'd used a CoreXY layout for this 3D printer design. This layout keeps the X and Y motor stationary, which reduces moving weight and allows higher speeds. The Z-axis would ride on a pair of linear rods and be driven by a lead screw. For the extruder, I picked up this BMG clone for about $6 on AliExpress. For the motors, I chose NEMA 17 size steppers instead of the NEMA 14 motors commonly seen on printers of this size. These are cheaper, can produce more torque, and if you have an old printer laying around, chances are you'll have some already. Rounding out the parts is the Voron Zero heat bed. I forgot to take a video of it before installing it on the printer, so here's a clip of just the print surface. With all the parts decided, I fired up Fusion and started on the main design. A big focus of this design was modularity. The main assemblies, such as the CoreXY mechanism and the Z-axis, are designed to be easily swappable and upgradable. The printer has no internal frame, but is held together only by its side panels. Each panel is only about 1.5mm thick, but when fastened together, they create a super rigid structure. I also made them small enough to fit on typical 3D printers like the Ender 3. The CoreXY gantry design places the motors at the far back of the machine. The front of the printer is totally unblocked by belts, making it easier to remove prints. For belt tension, I added sliding mounts to each motor. It's a bit crude, but gets the job done without adding any additional parts. The print head was designed to be as compact as possible. The Bambu hot end has its fan on the left, while the right side has the X end stop switch. In front of all this is the print cooling fan. The Z-axis is relatively simple, with 2 linear rods and a lead screw handling vertical movement. A pancake motor at the bottom saves some vertical space. The extruder fits perfectly between the X and Y motors, and while I originally had the power supply on the bottom, I realized that there was just enough space to put it right behind the Z-axis. This frees up the bottom of the printer for the controller board. And that just about sums it up for the design. With the initial design complete, it was finally time to start the build. I originally wasn't planning on making a full-length video and didn't record the build process, so enjoy this quick photo montage instead. After a relatively smooth build, but a much less smooth tuning process, I got things working pretty well. Running the Bambu hot end in a Bowden setup made for a lot of tuning difficulties, so I might consider making a future version with a direct extruder. I eventually was able to get the extrusion issue sorted out, so I moved on to the next issue, which was weak cooling. Swapping to a thicker fan helped, and I also tried out a bunch of different cooling shroud designs. I eventually landed on this nozzle, which blows air onto the print from 3 sides. To boost cooling even more, I added 2 large side-mounted auxiliary fans to the design. For filaments like PLA, this allows the print time to be shortened dramatically, as the improved cooling allows for lower minimum layer times. With higher print speeds came another issue. The print bed would start to vibrate past a certain speed, causing the nozzle to dig a wavy pattern into the perimeters. Turns out that the 6mm rods and bearings that I originally used in the Z-axis had a fair bit of play to them, and swapping over to 8mm rods got rid of this problem completely. The modular design made it straightforward to swap out just the Z-axis without affecting any of the other assemblies. After this upgrade, this little machine has been able to churn out parts super quickly. The combo of high speeds and fast startup times makes it more convenient than my Bambu A1 for prototyping small parts. The print quality isn't bad either. Here are some example parts that came off this machine. The layer stacking is very consistent, and ringing is well controlled because of the low weight of the gantry. There are still some extruder hiccups, so I might need to do some additional tweaks to fix them. Overall though, it performs remarkably well for something with a fully printed frame, and it's at a point where I feel that it's ready for release. So with that in mind, I've put out the full set of design files onto the GitHub repository linked in the description. This project is still very much a work in progress, and I still have to add documentation, so be sure to check back regularly for updates. All in all, I'm super happy with how this printer turned out. It now sits right next to my A1, and I often have both of them going at once. With everything fully operational, all that's left is coming up with a good name. It took a while to come up with a name I liked, but I've decided to call it the Encore since it's a perfect second printer, and it's fitting that a CoreXY printer has Core in its name. Bringing this project to life has been a ton of fun, and I hope you've enjoyed following it as much as I have enjoyed building it. Thanks for watching.